Okay, we're going to look now at how we calculate the heights of low and high water for a secondary port in the Pacific. So it's the heights of low and high water for a secondary port, and the secondary port in the Pacific. Okay, in this instance we're looking to find for Tauranga the heights of low and high water on the 4th of June. Okay, we looked in the tables. We found Tauranga, we had the ATT number, we found Tauranga, and we found that Auckland was the standard port. So we then went into the tables at Auckland, and we got, on the 4th of June, the times and heights of low water and high water. So we've put them here. For the 4th of June, we've written low water, high water, low water, high water, 0.63, 0.4, 3.2. We've written the values there. Okay. So there are all the values there for Auckland. Okay. The first thing we apply is the seasonal change, which is the same as we looked at for European ports. And the seasonal change for Auckland, we look up 6400 at the bottom of the book. We look up 6400. It's not on that page there. We go over to the previous page. And we can see 6377 to 6526. It tells us that value is negligible. So that means there's no correction to apply. It's the same principle with the Pacific as it is with European. With the standard port, if you have a correction, whatever it's given in the back, if it's plus or minus, you change it. So if we'd have had a +1, for example, here, we would have put -1 in here. So you change the value for the seasonal change. So the value was negligible, so we've got 0 all the way along there. So our astrotide for Auckland is the same value as the initial values we got from the tables. Now let's look at how we get the height differences. Okay, and that's by interpolation. If we go into the tables for Auckland, and we've got Auckland and Tauranga here, so we've got Tauranga and Auckland. At the top there for Auckland, for high water, spring and neaps, we've got values of 3.1 and 2.8, low water 0.8 and 0.4. So we've written here 3.1 and 2.8 for high water, 0.8 and 0.4 for low water. For Tauranga, we've gone along and we've got the values for high water, springs and low water, high water springs and high water neaps. So the high water values, we've got -1.3 and -1.2. For the low water values, -0.4, -0.1. We've written those values in there. Okay, so we've simply taken the values at the top of the high water and the low water for Auckland, and then we've gone to Tauranga and got our values again for high water and low water in the corresponding columns. So we've written them down here. Just to reiterate, high water Auckland 3.1 for springs, 2.8 for neaps. First high water Auckland is 3, so it's between 2.8 and 3.1. So our value for Tauranga must be between -1.2 and -1.3. So what we do, we get the difference between 3.1 and 2.8, 0.3. Difference between 1.3 and 1.2 is 0.1. So if it's 3, what we do, 3 to 3.1 just gives us a value of 0.1. So we take 3.1 from 3, 0.1, divide it by the difference, 0.3, and multiply it by the difference for Tauranga. Gives us a value of 0.03. So we apply 0.03. Now we're going from 3.1 down to 3.0. 3.1 to 3.0. So we go -1.3 towards -1.2. So our value is -1.27. So we write that value in there, -1.27. The next high water value is 3.2. Now in this instance it's higher than the 3.1, so we need to extrapolate. So 3.1 to 3.2 is 0.1 over 0.3, which is the difference, multiplied by 0.1, which is the difference for Tauranga. We get a value of 0.03. Because we're extrapolating, so 0.1 over 0.3 times 0.1, Tauranga difference 0.3. Because we're extrapolating, then we're going from 1.3 that way, because we're going from 3.1 to 3.2. So therefore our correction, minus 1.3 plus 0.03, it becomes minus 1.33. By extrapolation it's minus 1.33, which is what we apply there. So that's the high water values. We had 3 and 3.2, 3 and 3.2, and we applied them to get our values. Let's look at low water. First of all, we've got 0.6. So 0.6 is between 0.4 and 0.8. So our value must be between minus 0.1 and minus 0.4. So 0.6 from 0.8 is 0.2, divided by 0.4, which is the difference between the two, multiplied by the difference for Tauranga, 0.3. We get 0.15. So we apply 0.15 and we're going from 0.8 to 0.6. So it's minus 0.4 minus the 0.15. So we get a value of minus 0.25, which we write in there. The next low water Auckland we get is 0.4. Let's go to the values for low water. We can see that Springs is 0.4. So there was no interpolation needed here. We just simply use this value minus 0.1. Had the value been 0.8, we'd have used that value minus 0.4. But because we've got a value of 0.4, we just simply apply the minus 0.1. We apply all those values and that gives us our astrotides for Tauranga. We've just simply subtracted the various values. Then we go in again and look for the seasonal change for Tauranga. Now the seasonal change for Tauranga, we do not change the sign. So if it's plus or minus, it stays at plus or minus. Now Tauranga is 6415. So we go in at 6415 and we can see 6377, 6526, it's negligible. So that means there's no correction to apply. So it's 0 all the way along. So our predicted tides for Tauranga are now low water, high water, low water, high water, the values you see there. So initially we got the values for Auckland from the tables. We applied the seasonal change for Auckland, changing the sign. That gave us the astrotide for Auckland. We calculated the height differences by interpolation that we've got here. That gave us the astrotides for Tauranga. We got the seasonal change from the bottom of the book for Tauranga, applied it there, and it would be, if it was plus it would be plus, if it was minus it would be minus. That gave us the predicted tides for Tauranga. So that's how you calculate for a second report by interpolation and extrapolation the heights of high and low water going from standard port Auckland to the secondary port Tauranga.